Hello and welcome to my channel. In this video we are going to solve a question from trigonometry, and this question has 3 sub-questions. So let us start with the first question now. Calculate angle ADB. So here in this given figure we are supposed to find out the angle ADB, that is this angle. So for this let us consider the triangle ADB first. Now to find out this angle we are going to make use of the cosine rule, because the 3 sides of a triangle are being given to us and we have to find out a missing angle. So let us write the cosine rule. So under the cosine rule we have cos of the missing angle, that is cos of angle ADB, is equal to sum of square of the 2 sides which are attached to this angle, that is AD square plus BD square, minus square of the side which is opposite to this angle, that is AB square, divided by 2 times the sides which are attached to the missing angle, that is AD times BD. Now since we have been given the lengths of all these sides, let us plug in all the values in this formula. Now the length of AD is 8.6, so 8.6 square, plus the length of BD is 9.7, so 9.7 square, minus the length of AB is 4.4, so 4.4 square, over 2 times 8.6 times 9.7. Now before we solve this, let us take the cos on the other side of equal to sine. So we get angle ADB is equal to, when we send the cos on the other side of equal to sine, it becomes cos inverse or arc cos of the given fraction. Now let us take this entire thing on the calculator and get the value of angle ADB. So I have put this entire thing in the calculator. So here we get the angle as 26.973 degrees. Or rounding it to 1 decimal place, we can write it as 27 degrees. So here we have written angle ADB is equal to 26.97 degrees or 27.0 degrees. So this is going to be our answer. Now let us move on to the B sub question. Calculate the length of DC. Now since this side belongs to the triangle BCD, let us highlight this triangle. Now in this triangle we have 2 angles with us. So we can find out the value of angle C by using the angle sum property of the triangles. So using the angle sum property of the triangle, we have got the value of angle BCD as 180 degrees minus the 2 angles given to us, that is minus 65 and minus 42. So this is going to give us the value of angle C as 73 degrees. Now once we have found this angle, we are supposed to find out the length of DC, that is this missing side. So for this we are going to use the sine rule, because we have the angle and we need to find out its opposite side, and here we have found out the angle C and we have the length of the opposite side to it. So under the sine rule we have written the length of BD divided by the sine of the angle opposite to it, that is sine of angle BCD, is equal to the length of the missing side, that is DC, divided by the sine of the angle opposite to it, that is sine of angle CBD. Now once we have written the sine rule, we are going to plug in the values. The length of BD is 9.7 over sine of angle BCD becomes sine of angle 73 is equal to DC over sine of angle CBD, that is sine of angle 65 degrees. Now taking sine 65 on the other side of the equal to sign, we get DC is equal to 9.7. Now sine 65 gets multiplied with 9.7 over sine 73. So let us see what value this gives us. So this is going to give us the value as 9.19 centimeter, or rounding it to 1 decimal place as 9.2 centimeter. So this is the length of DC. Now let us move on to the last sub question. Calculate the shortest distance from C to BD. Now here we are supposed to find out the shortest distance of point C to the side BD. So let us highlight this triangle first. Now here we have written the side DC as well, as we had got its value in the previous question as 9.19 centimeter. Now remember that whenever shortest distance is asked, we have to find out the perpendicular distance of the point to the given side. So here the shortest distance is going to be from point C to, let us call this point as point E. So here we have marked this point on BD as point E, and this is going to be the perpendicular distance. So in this question we have to basically find out the length of CE, and for this we are going to use the right angled triangle CED. So let me redraw this triangle over here for easy reference. So this is the right angle triangle CED, right angled at point E, and the length of CD is with us as 9.19, and the angle D is given to us as 42 degrees. And we are supposed to find out the perpendicular distance, that is CE. Now here we have to make use of one of the trigonometric ratios to find out the length of CE. So we have the angle of concern as 42 degrees and the side opposite to it is CE. So this becomes the opposite side. The side which is opposite to the 90 degrees will be always the hypotenuse. So here CD is opposite to the 90 degrees. So this becomes the hypotenuse and the remaining side default becomes the adjacent side. But here, since we need to find out the length of CE, which is the opposite side, and the hypotenuse is with us, we do not need the adjacent side. And the trigonometric ratio which uses the opposite side and the hypotenuse is sine. So here we have written, consider the right angled triangle CED. So sine of angle CDE is equal to the opposite side over the hypotenuse. So sine of angle CDE becomes sine of 42 degrees is equal to the opposite side is CE over the hypotenuse length is 9.19. Now let us take 9.19 on the other side of the equal to sign. So we get CE is equal to sine 42 degrees times 9.19. So let us see what value this gives us. So this is going to give us the length of the shortest distance between the point C and the length BD as 6.149, or rounding it to 2 decimal place, we get it as 6.15 centimeter. So this is going to be our answer. I hope you have understood all the steps and liked the video. And if you found this video useful, then check out this playlist where you'll find more examples of this kind. And if you're liking my videos, like, share and subscribe to my channel. And thank you for watching.